Hi, this is Mark. In this video, I'm going to talk about the filtering of information. So typically, this could be problematic for certain areas, certain conditions. But another thing to consider is anytime we have like conditions, let's say we have conditions, we can call them conditions x1, x2, xn. So this could be like we have a lot of mental conditions and there's a lot of stigma out there, and this is basically fed into like a set of elements. And this set over time is expanded actually disproportionately in the past century. And a lot, there's many reasons that we define these conditions. Partly, there exist. Well, I wouldn't say it doesn't exist. How would I put it? It's more of subjective terminology, but we tend to define. So we tend to define normality. And so we tend to define normality and we try to constrain society based on this. So basically, let's suppose there's a boundary. Here's limit 2 and here's limit 1. So we can define, neutral axis. This doesn't really exist, but we subjectively, if you ask someone what is normal, they may or whatever, they give you an answer or not. A lot of times it's going to be based on what the majority, where the majority stands, where the density, like if you have a population and you have ideas, it's where where you have a density or high density or population of in terms of these ideas. So if you target like a range, if you shoot an arrow at a target, you're going to hit that. So it would be analogous to this. You have an arrow. You shoot the dart, and then there's another idea, and then there's another idea, and you're going to get this region. You're going to get this region. Probability is going to be high that you're going to be within this region. And then from here we spit out like normality. But it doesn't really exist. It's a subjective term, but this is kind of where a lot of these conditions come from. You may exist somewhere here. Here, you may be here. But then when you deviate beyond these boundaries, they want to, it's like the force that can, we define these conditions to try to enforce, constrain society within this bound, but through objective means, objective measures. And yes, there is a lot of, truth to a lot of these conditions, but there's a lot of corruption as well, so I'm not really going to cover. And some of them, like in terms of the defining region, it's loosely defined. So this isn't like just because this point we define as an outlier. In the future, this limit may expand. And then in the future, this is within the boundary. And, it could go like this. It could, and a lot of times likely, as we learn. So this exists. That's why, like, we had the Dark Ages, or there's times when there's witchcraft and basically there's these ideas that, were outlandish. So, you have outlandish ideas, and were persecuted. They were persecuted due to outlandish ideas. But of course, a lot of them were, like back in the day, we believed that, some people believed the Earth was flat, and of course, the probability of us having that belief, if we were to revert back to that level of complexity, it would inevitably be higher. Of course, we have more uh, knowledge. And in terms of, I was going to get into filtering. Filtering is like part of a condition coexisting. There's a lot of overlap too. So, like, if you have a condition, there's X traits. Well, there's another condition, and there's going to be overlap. There could be another condition. Oh, and they may overlap within all three. And then, therefore, there could be another condition. So it gets very, very complex once you zoom into this system. And especially, when you get down to it. So you try to get a global picture, but that's not, ultimately, it really depends on the time, like the current, the evolution of where we are, where we stand, how we define things. It gets more precise usually over time. But in terms of like filtering information, this is it can coexist with a lot of conditions, like I mentioned, ADHD, even mania, and the bipolar. The filtering goes down. So filtering, like mental. So we have mental filter. So this is basically what ends up happening. So if you're taking in multiple inputs, and then as these are, there's this region where the bits of information go through this filter, and then they come out with less frequency. Usually the filter, say you have n bits. Well, then here you're going to have, let's just say this is n prime bits, and let's just say here we have n bits, where n is less than equal to n prime. The reason is, so therefore we can define filtering is proportional, or it's proportional to the distance between n and n prime. So suppose now you filter nothing, like if nothing comes out. So if n equals 0, well, you start with 0. Let's say n prime's over here. Well, another case is we have n, 0 is less than n is less than n prime. It could be here, could be here, could be here, could be here. But as you go in this direction, the filtering is becoming less. And then, of course, we have n equals n prime, where n prime, and this is n, it's right here. So basically, if you draw a function, so we go distance, and degree of filtering. So degree of filtering, if the distance is 0, we can imagine it. There's a very high degree of filtering. It's basically, it's absolute, like you're filtering everything. How would this say? I mean, we can define this as like in terms of the maximum limit is the distance n prime minus 0 is n prime. And then basically it's kind of like, it's an inverse relation. So as the distance increases, so as you tend in the other direction from the, as the distance becomes increasingly large. So the first case, if n equals 0, the filtering is extremely high. But as n approaches n prime, there is no filtering. So basically you filtered nothing. So, I mean, we can make this like, I guess we don't really know the function. We just know it's an inverse relation. So basically it decreases with the as the distance um, approaches n prime. So essentially, in this case, what we're doing is if we have n prime bits that come out of here, well, the filtering is basically nullity. And this can be it can be a problem, but it's to me, I find it's interesting. It's really it's a mode, or it's a style of processing. A lot of times filtering is also proportional. It's proportional to like creativity, divergence, or related, processing speed. There's many reasons why filtering could go down or be floored. For instance, like if processing speed increases, now we're gonna imagine right here at time t equals 0. So let's just say processing speed SP, denoted as SP. So SP, equals P naught. That's the initial processing speed. So typically during like a day or an event frame, so if we take like a frame, so typically we can divide time into multiple frames, and we can even zoom in, and get a more accurate depiction. But as time is flowing, time is flowing, what we end up finding, processing speed changes. So within these event frames, let's just say event frames, we're going to call this as time like frames, like if we have a time range, we could have 0, t equals 0 to t equals t naught, and this is the initial, and then we go to t equals t1 iteration. So this is event frame, and this would be frame 1, and so forth. So we could call this like EI. EI is just a distance between here. And so event frame 1 would be here. Event frame 2 would be this distance between here to here. So forth. ... Typically, there is a cyclic range. It makes sense. During the day, many variables change. So you're gonna have like your energy dwindles. You may exercise, so your processing speed increases temporarily. You could, take drugs. You get a spike. You can do multiple different things. You can meditate, and therefore increasing the alpha waves. Many reasons why, and therefore during these frames, you could start here, and usually within if you zoom in, you're going to get minute, changes, but you may have, as you go on, you could have a spike and intermediate. But the thing is there exists like a neutral zone, and so long as it doesn't scatter so rapidly, typically there's like a distance between here to here. But if this happens, like this spike right here and this dip, if it happens within a short period, the adaptation process is not really an issue. The adaptation is proportional to this neutral axis. This is like what we adapt to. And so long it's not, usually it doesn't oscillate so rapidly. I mean, you get small, minute, and we adapt to eventually. It's like going on traffic. You know, you're driving down the highway, certain velocity. It's not like, or you could be going on the highway for a long period and then suddenly, abruptly, you get off and then you have to go down to a, lesser pace. Well, because you adjusted to that, it seems as if, because you're going at higher, that you're actually going slower, even though at that level, because you have to adapt to it. The slow speeds seem as slower because you're adapted to the high speed. But ultimately, with this, is we adapt to some processing speed, and for the reason, in terms of filtering, we know that there's something, we know a concept where it's called chaos. So we know, or there exists a limit such that the mind can no longer organize bits of info. So, if you consider a frame, you have one bit to process. Okay? And let's say your adaptation, let's just say you adapt to average of, let's say, 10 bits per frame. Okay, we're rates, so we can let, no, rate is 10 bits per frame. Okay, so, now we have 2. Perhaps we connect these pieces together, and then, so forth, so it'd be easier. And, but, we don't necessarily, we could take it, and perhaps we connect this, and we may connect this, or we may connect this, and, so forth. Or not, but as we keep going down, and we keep cycle, if we go towards now chaos, let's just say this is like, we can imagine it's just for, 100 bits per event frame. We're tending towards infinity. So there exists some limits. So as a function, mathematically, if we have this function, we can define this limit. And essentially, so we could just say, like, this is time and this is the rates. If we increase it, so if we're increasing at a certain rate, well, this is chaos. We pass the limit, and we're in, like, this chaos could be like psychosis, it could be schizophrenia, we get, like, disorganized. The filtering, this is where, like, filtering is poor. So this is one area. Processing speed can relate to filtering, but not necessarily. It could be like even personality, or just divergence, like a divergent mind may seem to lack a filter. And it could be just because you have, like, if you have an influx of so many, ideas coming in. The key piece is if you can organize it. Because a lot of times filtering, has to do with, like, let's suppose, like, you suppose if you hold very firm beliefs, like science, we know science, for instance, like science is a bounded system. What I mean by that, this is an upper bound. Science started as a point. We didn't know anything. It has increased in magnitude. But science continues to increase. We are here. We exist here. We are shifting in this direction. There could be a point out here. Let's say, so we take a leap. This point could be absurd now because it seems so it's so outlandish. It's so far outside the bound. But it's still possible. Now, as science expands and we catch up to it, oh, it makes sense. This is like, back in with Tesla, he came up with like ideas that were well ahead of his time. He took a projection, Newton, all these great scientists, they went into this chaotic region. And this is where filtering, you have to, this is where you deal with chaotic, a lot of speculation, and if you only reside within here all the time, it's easier to filter, because filtering, you filter what is relevant. But so a lot of times, if you're like, this would be like objectivity. We have facts, stats, ... But there's more to it than just these. And basically, if you believe, like, if you have all these, ideas or divergence, it can definitely lower the filtering process, because it has to do with the funneling. What is coming to the mind, what you are open to. So this is there's also something called low latent. It's called low latent inhibition, and it correlates strongly with creativity and openness to experience. Low latent inhibition, what happens, and this relates to processing speed as well. So if you're here, we have a range of perception that exists within, upper bounds, or, bound. These are just two bounds. And everything's funneling in perpendicular, it's just funneling in. So typically, with latent inhibition, the mind becomes less receptive to information that has been already categorized by the mind. So if the mind tends to focus on what is novel. So the key is its novelty. Of course, this, induces reward feedback. But with latent inhibition, what latent inhibition does, so let's say degree of inhibition, and this is like reward feedback, it gets floored. And because of this, it approaches, as degree of inhibition approaches infinity, the reward feedback approaches zero. This is for repetitive events. So if you already soak in an input, this, or like this is for non-unique inputs. So therefore, if you soak in it like an input, and you have a repetition of the same input, the reward gets floored very fast with inhibition. So you're basically, you categorize it already and it's not deemed as important anymore. So now when you have low lane inhibition, you have a problem with that. You're still pulling in, you're still open to the stream of input and therefore flooded with more input. So this is why it relates to processing speed and therefore why it relates to the filtering. And it can diminish the filtering. But it is related to creativity. So we know filtering is related to creativity. Low filtering, so like low filtering implies open and creative. And the positive side, obviously, psychosis on the negative side. And we have high filtering. Well, this just implies it's tends to be how would I put it? Usually structured, organized. It doesn't necessarily, and this positive side, and then of course on the negative side, obliviousness on the negative side. So, or like this could be like hyper focus or narrow focus. Could be in instances. But of course, high filtering, you could be creative as well. So it's not like, yes, low lane inhibition just means you're creative. It just means the likelihood is generally higher because you're pulling in more inputs. Therefore, when you pull more inputs, you have more possibilities that exist and more linkages. And when you have more linkages, you can utilize that in a constructive way. But does creativity stem from just low lane inhibition? No, it's generally stems from it's a personality. It's more than just personality, but it's very deep into ingrained within the psyche or the development. It's something that we don't even know fully, absolutely. So there's many reasons for that. And yeah, this is just a video to explain the filtering process. And I'm going to stop right here and I'll see you next time.